Welcome back. You may have noticed something while talking about Big O. Scalable means we worry about large inputs. What does the end of the graph look like? So if our function is only worried about really small inputs, or we know that our inputs are only going to be, let's say, an array of 5 items, Big O won't matter as much, does it? Because over here, if the elements are small, all these lines are kind of bunched up together. They're all the same. But is that real life? No, because as humans, we tend to think in here and now. We tend to think that, our website's only going to have 100 users. That's it. But what if that user base grows? What if our inputs grow? We never know. When we write code, we want to write code that can scale so that we don't have to constantly go back and fix things, or when things get out of hand, the code breaks. And that's why Big O is so important. To write scalable code means thinking outside of just this small little section over here. It means thinking long term, thinking big about your code and what could happen in the future. Now, you're thinking to yourself right now, hey, Andre, I feel like I just learned a whole bunch of theory and no practical information. Andre, I want to know exactly how I can use this in my day-to-day life as a coder. I'm kind of getting bored here. Well, with this newfound knowledge, you're going to look at code differently now, right? Let's have a look. You see, now when we look at methods that we get in a language, such as methods in an array, when it comes to JavaScript, we have things like push, pop, shift, unshift. You see, all these methods, which are functions, have a cost associated with them, a Big O cost. For example, when it comes to arrays, when we search for an item, or when we access the first item in an array, for example, it's O of 1. But when we use something like unshift, well, it actually turns out to be O of n. And why that is, we're going to get into when we talk about the data structure array in the data structure section. But you're going to start to see for the rest of this course how we use Big O to measure why one data structure might be better than others. Why should we use an array instead of, let's say, an object? Maybe object has better functions that we need for our data. This graph that we've talked about up until now is actually part of bigocheatsheet.com. And if we scroll down here, you'll see that each data structure, that is an array, and in this case, objects on this table is a hash table. Again, something that we're going to cover in the data structure section. But we see that we have different Big O notation for different data structure. And some data structures have really good search Big O. Some have insertion, some have deletion. And you can see here that there's different pros and cons to each of these data structures. As you'll find out in this course, data structures are simply ways to store data, and algorithms are simply functions or ways to use data structures to write our programs. Remember our instructions for machines, for our computers. And great programmers have this knowledge where they pick the right data structure, the right algorithms to write good programs. Remember our 2 rules of good code: readable and scalable. And what we've learned is the foundation for us to make a decision of which data structure is going to be best when we get into the data structure section, because we're going to know, arrays allows us to access at O and 1 constant time. But when it comes to searching through an array, it's going to give us linear time versus perhaps maybe an object. So behind the scenes, even though this section may be a little bit theoretical and boring, what we've just learned is going to lay the foundation for the rest of the course for us to be able to write good code. For the rest of the sections, we're going to use Big O to see what is a good solution to a problem and what is a bad solution to a problem. And most interviews have this core concept. What's the right data structure? What's the right algorithm to write good programs? Google hires engineers and developers that know this because they have a lot of scale that they have to think about, a lot of inputs. And people that know how to handle these programs are the ones that are going to be able to build great programs. I'll see you in the next one. Bye-bye.